Hello everyone, I'm Graham Lewis, and in this video we're going to discuss how to add together consecutive integers and develop the sum of the first n terms of an arithmetic series, n over 2, 2a plus n minus 1d. So let's start with, a long time ago there was a famous chap called Gauss, and he was in class, and apparently the class was being quite naughty, and so the teacher asked them to add together the numbers from 1 to 100 to keep the class quiet. And he thought this task would make them quiet for a long time. Gauss very quickly said the answer, 5050, and the teacher said, "How did you do it so quickly?" He was expecting them to add them consecutively. What Gauss did is he realized if he added the first and the last number, he got 101. If he added the second number and the penultimate, second to last number, he got 101. And as he had 100 numbers, he realized he had 50 pairs of 101. So this sum was actually 50 times 101, which is 5050. Now, I wonder what Gauss would have done if the teacher hadn't said add together the first 100 numbers, but what if he'd asked add together the first 99 numbers, because now you don't have an even number of numbers. I'm just going to pause the video for you to think about that question. So hopefully you're thinking, and you've had to think about how you would add together the first 99 numbers, and you've had a pause and a think. Of course, one way is to add together the first 100 numbers and then just subtract 100. Or you could try and think, well, I've got 49 pairs and I've got a middle number, and what's that number? But here's another way of doing it. Imagine, and I'm going to do, say, the sum of the first 5 numbers. Imagine we were doing 1 plus 2 plus 3 plus 4 plus 5. We don't have an even number of numbers here, we've got an odd number of numbers. Let's write the sum backwards, which is the same answer, 5 plus 4 plus 3 plus 2 plus 1. Notice what happens if you add your sums together. Firstly, we'll get double the sum. 1 add 5 is 6, 2 add 4 is 6, 3 add 3 is 6, 4 add 2 is 6, 5 add 1 is 6. So, and how many 6s have we got? 5 6s. So a quicker way of writing that is I've got 5 lots of 6s, which is of course 30, and that's double my sum. So my sum is actually 5 times 6 over 2, so 15. So let's generalize this now for the first n numbers. So what we've got here is the sum of the first n numbers. 1 add 2 add 3 add ... keep going, and the last 3 terms will be n minus 2, n minus 1, and n. Let's write it backwards just as before. So the sum of the first n numbers is n plus the next one would be n minus 1, and the next one would be n minus 2 plus ... plus, and then it would be a 3 plus a 2 plus a 1. As before, let's add them together. Now, the beauty of this way of writing it backwards and adding them together is, of course, you're not worried whether n is an even number, you've got an even number of numbers, or an odd number. It works for both. So double my sum is 1 add n, which I'll write as n add 1. That's that, add that. 2 add n minus 1. Hopefully you'll see that 2 add n minus 1. Well, the 2 minus 1 makes a 1 again, so I've got another n add 1. The next one is 3 add n minus 2. Well, 3 minus 2 is 1. I've got another n add 1. And they're all n add 1s. So all the way to the very last term, which you can see is an n add 1 as well. So every time you add the pair together, you get an n add 1. How many n add 1s do I have? Well, I've got n numbers. So 1 to n here, 1 to n here. So I've got n of these n plus 1s. I've got n of them. So basically, double my sum of the first n terms. A quick way of writing that, I've got n times n plus 1. And then I've got my formula for the sum of the first n terms of the natural numbers, 1 add 2 add 3, is n add 1 over 2. And that's how Gauss could work out the sum of the first numbers 1 to 100. He could say the sum of the first 100 numbers is 100 times 101 over 2, giving you the same answer, 5050. So that's a really neat way of adding the sum of the first consecutive integers. Let's expand this now to an arithmetic series. Imagine we had an arithmetic sequence going 1, 3, 5, 7, and so on, and eventually we want to consider what the sum of this series is. When we add them together, it's a series. 1 add 3 add 5 add 7 add, going on forever. Let's just have a think about the nth term first. So clearly the first term, n is 1, the second term we add 2. So we take the 1 and we add the common difference 2. To get the third term, we take the first term 1, add the common difference 2, and add another common difference 2, because it's add 2. So we've added 2 lots of 2. We're going to add a third lot of 2 from the first term. So start with the first term, add 2, add 2, add 2, add 3 lots of 2. So hopefully you've spotted to get the 10th term, you start with 1, and notice that we added 3 lots of 2 to get the 4th term, 2 lots of 2 to get the 3rd term, and 1 lot of 2 to get the 2nd term. So to get the 10th term, I add 9 lots of 2. And to get the nth term, I'd start with 1, and clearly I need to knock 1 off. So I'm going to add n minus 1 times the common difference 2. And that's our general term. And let's do that now for a general one. So imagine my first term is a. My second term, I'd have to add the common difference, whatever that is. It's gone up by a certain amount. To get the next term, I add another common difference. To get the fourth term, I would add 3 times the common difference, dot, 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 dot. To get the 10th term, I would add the 9th common difference, dot, dot, dot. To get the nth term, it would be a plus, and I'd have n minus 1d. So that's my general term of an arithmetic sequence. That for an arithmetic sequence going up by a common difference, the general term, Tn, is the first term a, and I'm adding the common difference n minus 1 times to get that general term. So we'll need that for proving our sum of the series of an arithmetic sequence. So let's have a look at that now. So the sum of an arithmetic sequence is the first term a plus the second term, which we know would be a add d. I'll put a bracket around that. The third term, which is a plus 2d, plus dot, 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 dot. It's going to get a little bit messy now. Now, we know the very last term, I'm going to write it, make this a little bit smaller here. No, write the very last term, which we know will be a plus n minus 1d, which we just showed. What would the term before that be? Well, it would be a plus n minus 2d. Let's see if I can just squeeze that in there, plus dot, 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 plus a plus, and it would be an n minus 2d, like that. The term before it would be an a plus an n minus 3d. Let's write the sum backwards, just as we did before. So this I'm going to write as an a plus n minus 1d. The penultimate term I'm going to write as a plus n minus 2d, plus the next term before that would have been an a plus n minus 3d, and so on. And my last, I've got 2 terms there. My last term is clearly a, and the term before it would be an a add d. So it's the same sequence, just written backwards. Now let's add them up in pairs, just like before. So Sn add Sn, that's double my sum, and this is where it gets interesting. I've got to add, I'll just grab a different colour here. I've got to add a, which is the first term of the sequence, and a plus n minus 1d is the last term. Well, a add a is 2a. So I've got 2a plus n minus 1d's. Plus, now let's add the next pair, a plus d, and an a plus n minus 2d. Well, a plus a is a 2a again. Now, let's consider this. I've got n, if I look at this here, I've got nd's minus 2d's if I multiply that bracket out. But I've got to add a d. So I'm actually, when I add a d, I'm going to end up with nd's minus a d, which again factors to n minus 1d's. So in other words, I've got the same thing, n minus 1d's. If I add the next pair, you can try it, you're going to get the same, 2a plus n minus 1d's. Add the very last pair there, again, dot, 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 plus, I'm going to end up with 2a plus n minus 1d's, which is really beautiful, isn't it? So what have we got here? We've got, when I add the first pair, 2a plus n minus 1d's. Add the second pair, 2a plus n minus 1d's, and so on. Every time it's 2a plus n minus 1d's. How many of those 2a plus n minus 1d's do I have? Well, I'm adding the first n numbers. So I've got n of these. I've got n of these 2a plus n minus 1d's. So double my sum is n times 2a plus n minus 1d's. So therefore, I've got a formula for the sum of the first n terms of an arithmetic series. Just divide it by 2, because I had double the sum, is n over 2, 2a, plus n minus 1 d's. And there you have it. So I hope you've enjoyed this video. A little bit on the long side, but I hope it's really interesting. And thank you very much for watching, and good luck with your arithmetic series and sequences.